Okay, number 2. Again, first thing I'm going to try to do is factor. And then if a whole shows up, that'll give me some slightly smaller numbers to deal with. And when I factor it, I get x plus 3 and x plus 2 all over x plus 3. And what do we notice? We got a common factor. So the x plus 3's divide out, and we're left with x plus 2. Okay, so already I know something about my graph. I know there's a hole at x plus 3, which means when x is negative 3, there's a hole there. Well, what's the y value opposite that? So what is f of negative 3? Well, that would be negative 3 plus 2, or negative 1. Okay, so I know there's a hole at negative 3, negative 1. Okay, now here's the beauty of this. When I reduced out that common factor, I now have a line. I don't have a rational function anymore, so I don't even have to worry about any of my other rational properties because I'm now looking at the equation x plus 2. Well, what does x plus 2 look like? Well, it crosses the y-axis at 2. It's a flat line with a slope of 1. And I'm wrong. I do have an error in my picture in that I know at negative 3, negative 1, so right here, there is a hole. So I'm going to make sure I get rid of my whole line. So I'm going to put a hole right there. And that's what that graph looks like. So there should be a hole there. Open circle. Anyways, so that's all number 2 is. Okay, number 3, same trick. I'm going to start by factoring. See if I get anything useful out of this. X plus 4, x minus 3. Let's see. Yep, that's right. And then the denominator, I get x minus 3 and x plus 2. Okay, so already I've found a hole, and I've reduced my rational to x plus 4 over x plus 2. Okay, so I have a hole at that common factor. So there's a hole at x equals 3. Okay, well, what's the y value opposite that x value? So I'm going to go into the reduced form. So 3 plus 4 over 3 plus 2, which is 7/5. Okay, so I have a hole at 3 comma 7/5. Okay, well, I still have a rational function, so I still have other things that I can identify about this. But now I'm just looking at this reduced form, that x plus 4 over x plus 2. Okay, so I know y-intercept, if I plug a 0 in, so that'd be 0 plus 4 over 0 plus 2, which is 4 over 2, or 2. So I know it crosses at 0, 2. X-intercept, if I take x plus 4 and equal that to 0, that gives me x equals negative 4. So at negative 4, there is an x-intercept. Okay, vertical asymptote. Look at the denominator. That's x plus 2 equals 0, so x equals negative 2 is a VA. And as far as a horizontal asymptote goes, this is an example of same. So I'm looking at x over x. So that puts a horizontal asymptote at y equals 1 over 1, or just y equals 1. Okay, so I have a lot of facts, and I'm going to claim, actually, we don't need a sign test on this one, and I'm going to try to convince you of that when I sketch the picture here. So let me get some lines in that I can draw. Alright, so let me start with the asymptotes. Let's go y equals 1. So there's a dotted line there. X equals negative 2. There's a dotted line there. Let's see. I have an x-intercept at 0, 2. So right there, there's a point. And I have a y-intercept at 0, 2. An x-intercept at negative 4, 0. So right there. Okay. Now I claim, and I have a hole. I have that hole at 3 comma 7/5. 7/5 is a little bit bigger than 1. So somewhere there. Okay. Well, what do rational functions want to do? They want to hug their asymptotes. Okay. So I'm going to take these points and I'm going to hug the nearest asymptote from it. So that has an asymptote, that has an asymptote. And up here, it's going to hug its asymptote that way. Okay, so in this particular equation, I had enough points that I could tell whether it was above or below the asymptotes, and I didn't have to go in and do a sign test. Typically, when you're given an HA of a number of some kind instead of 0, you can avoid the sign test typically, but not always. Okay. All right, we're going to factor first. Oh, sorry, go back to my initial color here. All right, factor first. So we got, let's see, x plus 4, x minus 3 over x plus 2 over x minus 2. Okay, so no holes, nothing divides out. So we are good. We'll just keep going from here. Let's see, so y-intercept, if I plug a 0 in, hopefully at this point you're like, oh, okay, that's going to give me negative 12 up top, negative 4 in the denominator. So that'd be 0, comma 12 over 4, which is 3. The x-intercept, if I go to the factored form and I set each of those things equal to 0, I should get negative 4, 0, and 3, 0 out of it. VA's, vertical asymptotes, would occur when x is negative 2 and x is positive 2. And then your HA is going to occur, let's see, it's a same case, so x squared over x squared, which means you're looking at 1 over 1. So that's when y equals 1. Okay, so let me fill in our information. Okay, so let me start with the asymptotes. I know I got one at negative 2, and I have one at positive 2, and I know I have one at 1. Alright, and I know I've got ordered pairs at 0, 3, and I have one at positive 2, and I'm sorry, no, negative 4, and at positive 3. 2, 3 right there. I can count. Okay. Alright, so two of these pieces, two of the three sections I think are pretty obvious, and then I'll just point something out and it'll make the middle section even easier. Alright, so this guy wants to hug the asymptotes, wants to hug, this guy wants to hug, and that. So on the two sides, they just want to hug their asymptotes. Okay. In the middle, let me kind of ask you a question and kind of make you think about the thing I want you to. Is it possible from that point in the middle that it could go down at all? Okay, remember, it wants to hug the asymptotes. So if it goes down, it's got to cross the x-axis somewhere, okay, on either side. But we already solved for all the x-intercepts in this graph. I know it doesn't cross the x-axis because I already know where it did cross, and it didn't cross anywhere in the middle, which tells me instead of curving down that it's got to curve up in both sides. And that would be what our rational graph looks like.